Alright guys, quick notes on the states of matter and phase changes, which are sometimes called changes in state of matter. A lot of this is probably already familiar to you with some kind of new stuff sprinkled in, so hopefully it'll come pretty easily for you. The first thing we need to really identify here is what really is a state of matter. So states of matter are the different physical forms that a substance can exist in, and there's really four big ones that we need to know about. It's solid, like here's an ice cube. Liquid, like we have water coming out of a faucet. There's gas, like the steam rising up off a hot cup of tea. And then the fourth one is plasma, which is like stars are an example of this. And we'll talk a little bit more about plasma in just a couple minutes. Now, when we look at solids first, when we look at a solid, these are things that their particles move really slowly and really they don't have enough energy to move past one another. So if this is a solid here, we have this particle here, it's kind of stuck and held in place by these other particles. So they're moving, they are vibrating, but when you look at the object as a whole, you don't see the movement of the particles. These particles are unable to slide past one another, so this means that the solid maintains its shape. The shape is not going to change. So the way we say this is we say that it has a definite shape. The shape is defined, it's not going to change unless some sort of outside force comes and acts upon it. So things like textbooks and ice cubes and candles are examples of this, where they're solid. The particles just vibrate in place, and the shape is maintained. Additionally, if I put ice cubes into a glass, the ice cubes still keep their shape, so there's our definite shape. But they also keep the same size. They don't expand or contract in their size, so we would also say that they have a definite size. So solids are substances where the particles move very slowly. They just kind of vibrate in place back and forth. They're packed really close together, and they can't overcome the attraction between all these particles. And the result of that is that we have substances with a definite shape and a definite size. Liquids, on the other hand, shift a little bit more. The particles are moving a little bit more quickly. They start to break a little bit away their attraction from one another, and this allows particles to kind of just slide past one another a little bit. And this is what allows liquids to change their shape depending on the container you put them in. So the liquids have particles that are fast enough to overcome some of their attraction and move past each other, and this gives them an indefinite shape, a shape that can change depending on the container that you put it into. But still the size remains constant. So while these particles can move past each other some, they don't have kind of free range to spread apart great distances from each other. So it can change the liquid from a glass to a mug to a petri dish. I can put it in a bottle, and it's always going to be the same size, but the shape will change to take on the shape of the new container. So liquids have a definite volume, a definite size, but they have an indefinite shape. They'll take the shape of their container. This is still different from gases, which now the particles have even more energy. Now the particles have more energy, enough so that they can not only move past one another, but they can spread apart. So these are faster moving particles. They can overcome almost all the attraction to each other. And this allows gases to change shape, but also change volume. So they'll spread out to fill up the container that you can put them in. This is why normally when you think about gases, if you're looking for an individual gas, it's probably held in some sort of container. Because if it was not, it would spread apart and fill the room that you'd be standing in. So these are going to spread apart pretty easily and fill whatever container you put them into for a gas. So we would say that a gas has an indefinite shape and an indefinite size. Now the last state of matter, which you're probably not as familiar with, is plasma. And there's some similarities between plasma and gas, but there are some distinct differences, and we really need to be able to identify the difference between them. So some examples of things that are plasmas are things like the aurora borealis, also known as the northern lights. Lightning is an example of this. Stars, fire. The difference here between a gas and a plasma, because a plasma has an indefinite shape and an indefinite volume, the same way gas does. But in gases, the electrons are still held close to the nucleus. They're still orbiting around that nucleus generally. But in a plasma, these electrons start to break apart from the atom. So you end up with a positively charged atom with some negatively charged electrons that are free floating around. We call this process ionization, and it happens as you add more and more energy into a gas. Eventually, there's so much energy that the atoms themselves start to separate. The electrons separate from the rest of the atom, and you end up with a electrically charged substance. This is a plasma. So plasmas have an indefinite shape and an indefinite volume, just like gases, but they have an electrical charge due to the increase in energy. So solids, we're jumping way back to solids here. Solids come in two different types. There's solids that have a very rigid structure, and if you kind of compare a couple solids, like a block of ice, if you tried to bend or reshape a block of ice, it'll break and splinter apart. But like wax, you can reshape and it'll bend, or like putty or things like this, you can bend and reshape relatively easily. This is because there are two different types of solids. There's an amorphous solid. This would be like a candle or like plastic. So like the wax from a candle, that is, or plastic. These are things that are amorphous. But things that are crystalline would be things like ice cubes or gemstones. These are things that have a rigid, very, very hard structure. So things that are crystalline solids will tend to like shatter as opposed to bend or flex. Things that are amorphous tend to be able to be reshaped relatively easily. Some interesting, something interesting to think about with other states of matter is that while plasma is a state of matter that you're not particularly familiar with, it is the most common state of matter in the universe. It's generally recognized that about 99% of the matter in the universe is in the state of being plasma. And that's because once you get off of Earth and you realize that most of the matter in the universe is in stars, which are a plasma. And then on Earth, it's things like fire, lightning, the northern lights, also known as the aurora borealis. These are other examples of plasma here on Earth, but throughout the universe, the vast majority of the matter in the universe is still in stars, and therefore is in the state of matter being plasma. There's something else that needs to kind of be discussed when we talk about the various states of matter, and this is liquids themselves. How some liquids flow really easily, like water, but other liquids like honey, for instance, or molasses, they don't flow very easily. And how resistant a liquid is to flowing is called its viscosity. So things like honey that are very resistant to flowing, these would be things that are referred to as having a high viscosity. Other things that flow very easily, like water or soda, these are going to be things that have a low viscosity or a low resistance to flow. If we're going to compare just kind of some quick diagrams to compare our different states of matter, like a solid, the parts are really close together so much that they're held in place. A liquid, they're a little more spaced out, they can flow past one another, and in a gas, they can spread out and fill a container. Now, I don't really have a plasma here, but it would look similar to a gas, but everything would be charged. So here's some kind of other views. And this all happens as we add in energy or take energy away. This also with energy, because it's the amount of energy in a solid that allowed the lack of energy, really the small amount of energy that prevents these particles from being able to spread apart. And as the particles get more energy, they can start to move past one another, become a liquid. As they get more energy still, they can now spread apart from one another. So if you think about water as a solid, it's an ice cube. And then if it sits out in the hot sun, it melts and becomes a liquid as it's taken in more radiant energy from the sun. The particles have more energy now and it becomes a liquid. It continues to take in more and more and more energy from the sun, and it becomes a gas in the form of water vapor. So the changes in state from one form to another really come down to energy. It's all about energy. So on your notes, there's like a mystery substance thing. Obviously, that's not something you can complete if you're utilizing the video, but if you're curious about that, you can kind of stop in and ask me. So we do have these changes in state, like a solid can become a liquid can become a solid, a liquid can become a gas can become a liquid. Kind of an interesting one, not everybody thinks about, but a solid can become a gas directly without becoming a liquid first, and a gas can become a solid without becoming a liquid first. And then gases, we can only go from gas to plasma and plasma to gas. We can't like skip any, for lack of a term, skip any of the other states. So I can't go from like a solid directly to a plasma without first becoming a gas. So these are kind of the shifts that we can make. And in looking at them, it always has to do with the amount of energy. So a change in state or phase change is just really a change of a substance from one physical form or one state of matter to a different physical form or a different state of matter. And it happens because of a change in the amount of motion that the particles can have and how strongly they're attracted to one another. So as you add in energy, the motion of the particles increase and the attraction between the particles decreases. As energy leaves a substance, the motion of the particles decreases and the attraction between them increases. So as we add in energy, like what would be happening with this ice cream cone here, the particles move from being a solid, they get a little more energy, and they become a liquid. And if they continue to add in energy, they would ultimately become a gas. The opposite is what would happen over here. So this is a kind of a neat picture I like, where a water main had broken and sprayed water all over these vehicles when it was cold, and then that water solidified, it became a solid. So in this case, it was really, really cold outside, so the water was losing some of its energy to the air, and as that happens, the particles slow down, they move less, and they become more attracted to one another, and they eventually transition from being a liquid into being a solid. And we have names for these processes, and you should be familiar with these. When we move from a solid to a liquid, we call this melting. You're probably very familiar with that. And then the opposite, when we move from a liquid to a solid, is called freezing. Now, there's something we need to know about these as energy, as we talk about energy as it relates to this. So the process of moving from a solid to a liquid means that a substance must take in energy from its environment. As a result of this, we call this endothermic. Now, you may have heard the prefix endo before with things like an endoskeleton, which is a skeleton that's inside of an organism. And then the opposite is true here. When a liquid becomes a solid, it gives away energy to the environment. So the losing of energy moves out of the substance. And so this is called exothermic, like an exoskeleton, which is would be the type of skeleton that an organism would have if it has its skeleton or its support system on the outside of its body. So we need to know those terms: endothermic, which means to take energy in, and exothermic, which means to transfer energy away. So solid, when we go from being a solid to a liquid, that process of melting, we're taking energy in, so it's endothermic. Liquid to solid, that's called freezing, and that would be exothermic. It would be the giving away of energy. So when we go from a liquid to a gas, these are some other ones you may be familiar with. There's condensation, which is when we go from a gas to a liquid. If you take a second, think, a gas is a high energy state, and we're moving from having a lot of energy in a gas to having a smaller amount of energy, a medium amount of energy in a liquid. So if we're losing energy, it means energy is being transferred out of our substance, and so we would call that exothermic. Vaporization, which is the process of going from a liquid to a gas, is taking energy in. So the substance has to gain energy as it moves from a liquid to a gas. So this would be called endothermic. Now, some of you might be more familiar with words like evaporation. Vaporization is a little more all-encompassing as opposed to evaporation, which happens just off the surface of a liquid. So we really want to stick with the term vaporization. And there's two major types of vaporization: evaporation and boiling is the other one. Boiling is when evaporation happens throughout a liquid. Now, these are ones you're probably not super familiar with when we shift from a solid to a gas or vice versa. The act of going from a solid directly to a gas is called sublimation. And an example of this is if you've ever been exposed to with dry ice. The reason why it's dry ice is it never becomes a liquid as it warms up rather. So it goes from being a solid directly to being a gas. This process, a solid is a low energy state, and that's changing to a high energy state in a gas, meaning that energy must be taken in, so it's endothermic. The opposite of that, going from a gas directly to a solid, which is what happens when frost forms on a car windshield or something like that. This is called deposition, and we're going from a high energy state gas to a low energy state solid. So that's going to be losing energy or transferring energy away from a substance. So that's going to be exothermic for deposition. Now, you do not need to be familiar with deposition in any great detail. That's of all the types of change that we've talked about so far, deposition is really not super, super important to you. And then the transfer from a gas to a plasma, you don't really need, or plasma to gas, you don't really need to be super familiar with either one of these, but you should have a basic understanding of them. When plasma loses energy to become gas, because plasma is an even higher energy state than gas is, when plasma loses energy and becomes a gas, that's called deionization. And the decrease in energy, the transferring of energy away, that's an exothermic reaction. And then when we go from a gas to a plasma, that's gaining energy. It's called ionization. And when we go from a gas and we increase the amount of energy to get to a plasma, that takes energy in, so that's called endothermic. So you should be familiar with those different changes in state. In particular, you need to be familiar with melting, freezing, vaporization, condensation, and sublimation. And you should be able to identify whether things are endo or exothermic and know what those words mean. So there's kind of lots of different examples. We talked about dry ice as an example for sublimation. Frost is an example. Forming is an example of deposition. Melting is like that ice cream cone or the block of ice. You certainly know what melting is. Freezing would be, if you put water into the refrigerator or into the freezer and it freezes, it becomes a solid. But it doesn't have to be water. I mean, it could be other things like when they make plastic toys, they heat the plastic up to become a liquid and then they let it cool. But when it becomes solid, it's called freezing. We normally think of it with water specifically, but it doesn't have to be. So that's kind of some stuff to keep in mind. Vaporization, you certainly kind of know what that is. That's you got that hot cup of tea and the steam that's produced. That's vaporization, or a boiling pot of water would be vaporization. Condensation, if you get out of a really hot shower in the winter and you have that water that's formed on the mirror, that's because of condensation. Or if you have a bottle of ice water and it gets wet on the outside, the bottle of water isn't leaking. That's just condensation. That's the water vapor from the air that's losing energy into the bottle of water, so that the water vapor, the gas state of water from the air, is turning back into a liquid through the process of condensation. So that's the basic gist of states of matter and then the changes in state of matter that you need to be familiar with. All right, have a good one.